Hi, welcome to another session of our online training for DSAS Package 1, Distribution System Loss Segregator, or DSL Segregator. Now, for this session, we'll be showing you how to analyze the results of the engineering attributes and how to interpret them and how to do the corrections. For this session, we'll be using a sample data where I deliberately made some errors that will produce results in the program. So first, I'll be showing you some of the errors I did on the data. In the customer energy consumption data, as we know, for the power factor values, we are only allowed to use values from 0 to 1. So for this case, from 0.85, I change it to 1.85. And again, the program will see this as an error and will report it accordingly. Now going to the primary line overhead. So here we have values for the spacing D12, D23, and D13. Now, if we will look at the configuration, it is a horizontal configuration. So as we know, for horizontal configuration, the sum of the distances D12 and D23 should be equal to D13. So for this case, the value for D13 is not equal to D12 plus D23. So you actually change it from 1.44 to 2.44. So again, the program will see this error and will report it accordingly. Another error I made is the number of DTs and connection data. So based on the standards by ERC, if we have two transformers in bank, we're only allowed to use connections 11 and 12. So for this case, I changed it from 12 to 5. And 5 is a connection that is only allowed for 3-phase transformers. So 3 or 4 for number of DTs in bank. So again, this will be seen by the program and it will report that it's an error. Another one is the conductor data for the secondary line. So originally it is CU1/0 AWG. I changed it to CU1/0 CM. So this value is not in our lookup table, which I will show you later during this session. So again, the program will report this as an error. So that's basically the errors I made on this data. So what we will do is we will save this data, and then we close it, and then we open the program for engineering attributes. So again, we go to the main interface of DSAS package 1. We click the button for data sanity checker, and then we click the corresponding button for engineering attributes. So again, what we need to do is just to select our input Excel file in ERC template format. So for our case, it's test_data2. So we open this data. Again, we check all worksheets here. It is automatically filled up by the program. And then we click the check input data. So the program inspected the data and produced the error report. So we click this button to view the main error report. Here you will see the summary of inspection results of the engineering attributes. So we have 4 error reports or error result for this data. First, we will see that there's an error in the customer energy consumption, which is found in this worksheet, and the field name is power factor, and then the field data is 1.85. This is a hyperlink. You can click that later on. It will show you directly where the error appeared in the data. You have the error message here. The value must be from 0 to 1, and it is found in row data number 14. So we click this. So it will directly show you or point you to the location of the error. So we have here the comment value must be from 0 to 1. So again, going back to the summary, we have here again number 2. The data sheet is primary line overhead. The field name is the configuration and spacing data fields. Again, we have here the field data, which later we will click this for the details. The error message which says spacing data do not form a logical construction pattern. This is found in row number 9 in our datasheet. So again, we click this, it will point us to the cause of the error. So we can see here that the error is basically the values of the distances. So for our case, we know that it is, or these values. So we can see that we changed it from 1.44, we made it 2.44, so that produced an error in our simulation. Now going back to the summary, number 3, distribution transformer. So the error is on the phasing, number of DTs and connection data fields. Again, the error message is phasing, number of DTs and connection or data do not correctly correspond. It's found in row number 4 in our datasheet. So we click this again. So here you can see the error that we made on the data a while ago. So from 212 we made it 25. So the program saw this error and it reported this error. Lastly, we have the secondary line, the conductor wire fields. We change this conductor size, and then the error message is cannot find conductor set in lookup table. It's found in row number 15 in our datasheet. So we can click this again, it will point you directly to the entry for that error. So it says cannot find conductor set in lookup table. So that's how you will check the results of the engineering attributes. So how do we correct these errors? Now looking at the result of the engineering attributes, we can see what we have here, all of the worksheets in our original data. So from customer data down to the bus data and sub-transmission data, to primary line overhead, to the distribution transformers, and to secondary line, secondary service shops, and all other worksheets. So basically this is a copy of your data which the program duplicates but only includes the EA error summary. So what you can do is actually you can use this worksheet. You can click this, you can make the necessary changes on the values. For example, for this case, correct this one, and then you go to another error, then you correct this error, and then you can go to this error again. We change this to 12. Then lastly, you can go to this error and make this AWG. So basically that's how you do the correction. You make the correction here in our worksheet, and then you save this one. Maybe well, you have to remove the EA error summary first, and then you save this as another data. So for example, in drive D, we save it as test_data3, and then you can start working on this template. So you can do that, or you can just use the summary and make it as a basis for the corrections, and then correct the errors on your original data, and then save it and use it again for further simulation. So it depends on you which one is simpler or which one you prefer. Now, just to add, for the conductor errors, let's go to the secondary line data. So we can see that this one a while ago was CM, and the program didn't see this value. So what you can do is go to the location of the lookup table, and then you can check why this size was not found in the lookup table. So it's found in drive C, program files, DSAS package 1, DSAS segregator, lookup tables, and we can see here an Excel file named lookup_tables. You can open that. So this is basically the lookup table for the engineering attributes. So we have a worksheet here for conductor. And this is the list of all the conductor sizes we found based on some written information and some references. So in case you have your specific size of the conductor that's not here in our lookup table, you can actually add here. Just make sure you have the corresponding attributes like the diameter, GMR, resistance in ohms per mile, inductance in ohms per mile, and ampacity. And you can insert that new conductor here, or you can place it at the last portion of the list. When the program simulates your data, it will find the conductor that you added here in the list. So that's basically how you use the engineering attributes, how you interpret the results, and how you correct your data using the results of the program. So I hope this will help you in the preparation of your data. So again, thank you very much.